Thanks everyone for being here. My name is Luke Hoban, and today I'm going to be talking about programming the cloud. And so when I talk about programming the cloud, what I really mean is sort of taking advantage of all these sort of amazing building block services that we have in the cloud providers today. Things from AWS, from Azure, from GCP, from Kubernetes, from every other cloud provider that we work with on a daily basis have amazing building block capabilities that we're now building on top of with all of the applications we're delivering. And what we really want to do is turn all those capabilities into something that we have at our fingertips, that we can really take advantage of in a really natural way, not hand over to some operations team to do something for us, but how can we as developers actually take advantage of all these capabilities directly. And so my interest in this topic sort of comes from my background and the things I've worked on over the last 15 years or so. And I spent the most of the early part of my career actually building tools for application developers. So building programming languages and IDEs and frameworks and that sort of thing at Microsoft. And so I helped start the TypeScript project at Microsoft. I did some of the early incubation work on what has now become Visual Studio Code. Worked on the ECMAScript standards body, a variety of these sorts of things. Worked on some of the tools that have helped application developers to sort of scale up the complexity of the applications that they build. I then went over and worked at AWS on EC2 and worked on sort of some of the raw cloud infrastructure that we have now available to us. Got a front row seat to sort of the rate of growth that's going on inside the cloud, and also a front row seat into how different the tools and practices are around how we're taking advantage of the cloud today. We do have these amazing building blocks, but they're not nearly as, the sort of tools and practices are quite a bit more sort of immature in a sense than what we have in the application development world. And then most recently, as Joe mentioned, joined him and a number of others to start a company called Pulumi, which is really focused on bringing these two things together. And I'll show some demos throughout here that use Pulumi, but really going to talk more about the general kind of problem and opportunity that I see here. So to give sort of a background and a sort of analogy for why I think there's sort of a problem, and analogize it to something which sort of folks may sort of have some understanding of. I want to start with sort of where application development was, say, 40 years ago. I don't actually know exactly how long ago it was that this was the state of the art, but some time ago there was the state of the art was I'm going to write assembly. This is how I'm going to build applications, right? This is sort of the best thing I have. And one thing that's really important to understand about this being sort of the best thing is that there was really a period in time where this felt like the best thing. By writing this kind of code here, I got access to computers. I got access to use computers to do computations for me that either would have been hard or potentially impossible for me to do myself. I got access to sort of the modern microprocessor, all of these capabilities. If I had the skills to go and learn how to use this thing, I had amazing capabilities at my fingertips. The problem was sort of looking from today's lens, this was an incredibly low-level way of working with this that would not have by itself scaled up. And we can look at sort of some of the things that are clearly missing from this from a kind of modern perspective. So there's things like, hey, there's no variables, right? So like there's no like self-documenting code where my variables have names that I can understand, right? I have to sort of look at these very complex sort of register names and offsets and that sort of thing. There's no loops. I have to sort of manually decode loops into branching constructs and that sort of thing. So I don't have any of these sort of basic control flow capabilities. I don't have functions, and this is sort of where it gets more interesting, is the ability to take a piece of code, write it once, give it a name, reuse that in multiple places. This kind of concept wasn't in this sort of low-level description of things. And more importantly, I don't even have the ability to sort of create abstractions. So these combinations of functions which then share a common data type that they operate on, and I can turn into a reusable library. All of this sort of capability wasn't really available here. An abstraction becomes really useful then when you build standard libraries out of it. You build libraries of these abstractions that solve for common use cases so that if people are going to rebuild applications for a variety of different purposes, they're going to reuse standard libraries that are available and shared amongst multiple people. And I don't have that here. Here I have to copy-paste the assembly code from one application into another to reuse it. And finally, once I have standard libraries, I kind of want types to describe what the APIs to these things are and to give me checking and validation over top of that ahead of time. And so, assembly didn't have any of these things, and you probably all know we sort of solved this problem by, introducing C, right? Introducing sort of a higher level language. It was a bit more tuned to what developers were actually doing. They were actually trying to, create reusable libraries, create abstractions, have a standard library, have types that they could use. And over the intervening, 20, 30 years, we've gone up the stack even further, of course. C these days is considered incredibly low level. And so now we've got, we had BASIC and then Java and then .NET, JavaScript, Python, what have you. Much higher level languages that take care of more and more of the sort of heavy lifting that we might have to do. And so one of my basic views is that sort of where we are with the cloud today is still very much in sort of this assembly world. It's this very low-level world of having to work with very low-level building blocks that are incredibly powerful, do give us access to these things that have a lot of capability, but there's so much opportunity still to move up the stack. And so I'll talk a little bit about that throughout the talk today. So when I think about sort of like what do I as a software engineer, like what are the things I value when I'm sort of looking at tools as a software engineering perspective, what are some of the things I like? And I won't talk through all of these, but folks probably, you know, sort of if you're doing application development today, you probably see some of these and like, yeah, those are important things to me. If I hit some application development environment where I didn't have access to, you know, high-level languages and I had to write in assembly, that would be bad. If I didn't have access to package management, that would be bad, right? These are things which generally are considered useful. And the interesting thing is that many of these really are not things that are available in the typical workflows around infrastructure today. In fact, there was a whole talk, for those who went to Jim's talk before this in this track, there was an entire talk just about how to do sort of unit testing and integration testing for infrastructure. These are not sort of solved problems. These are problems that still need you know, a lot of sort of work to kind of, and they're not the norm for folks to be doing this. And so I'll talk about a little bit more about a few of these as we go. But one of the things that folks may think, you know, if they're sort of especially coming from kind of the you know, DevOps side of things, may be thinking, well, the sort of solution to a lot of these problems that we kind of talked about on the last slide, all of these things we want from software engineering, the solution to this is infrastructure as code, right? It's taking my infrastructure and turning it into code and now using software engineering practices around that code. And this is actually really true. I think infrastructure as code is sort of one of the foundational tools that we have available to us to make infrastructure more programmable, more amenable to software engineering. The problem is, and there's a lot of tools for this. So many folks here are probably using one or more of these tools. There's CloudFormation and Azure Resource Manager for you know, the sort of major cloud providers. Terraform is very commonly used for sort of multi-cloud and cross-cloud kind of things. And then, of course, throw on Pulumi here, just because that's what I work on. But lots of tools around infrastructure as code that we can use. The problem is that most of these tools actually aren't infrastructure as code. They're infrastructure as text. And this is actually sort of an important distinction. Infrastructure as text is still useful. It means I can source control my files. It means I can still run CI/CD processes with my files. But it doesn't mean that I have all of the same richness of sort of software engineering capabilities as I have with code. And so what we really want to look at is sort of what does it mean to bring some of these capabilities of code, of application development, into my infrastructure. So to do that, let me start with a quick demo and sort of take a look at infrastructure as code with a focus on sort of the developer experience of things. And so let me come over here. Make this a bit smaller. All right. Is that readable? Relatively? Yeah. OK. Let me try to do this. OK. So I'm going to start with kind of an empty beginning application here. And I'm going to just write some infrastructure. But I'm going to do this in code, right? I'm going to do this in this case, in TypeScript. But with Pulumi, support a variety of different languages. And so what I'm going to do is I'm going to start by just writing that I want to have a bucket, right? So I'm going to say new aws.s3. And there's a couple of things we notice right away. So first off, I'm in Visual Studio Code here, so I'm sort of in an IDE. I'm getting that sort of IDE environment that I expect from sort of a rich development language. And I'm getting things like when I hit .s3, you know, when I hit dot here, I get access to all the different APIs that are available on my cloud platform, right? In the same way I get all the access to all the different APIs available in .NET or in Java or what have you. I'm getting all of that, and I'm directly within my environment. And then I get access to all the sort of different things in the S3 namespace. So I can create a bucket, and I get all the help text and all this sort of thing. So full kind of IDE experience here. And I'll just say I want to say bucket. Oops. OK. And now I want to just export the bucket name. OK. So now what Pulumi does is lets me take this code written in my language and just say Pulumi up to go and deploy it. So when I do Pulumi up, this is going to, first, it's going to preview my application. So it's going to say, what will this do to my cloud environment? So we're about to modify an actual running cloud environment. We want to give you a sense of what's going to change. In this case, it's telling me it's going to create that bucket. So I can see the details of what it's going to create, like here. And I can go ahead and say yes. So this is standard sort of infrastructure as code. The only difference is that I'm using existing programming language here, like TypeScript, to define that infrastructure as code. Now, because I've got this, I can then go and create more resources. So I can say const obj equals new aws.s3.bucket object. In this case, I want to sort of set a few different properties on here. So I can say I want this bucket object to live inside that bucket. I want its key to be obj, and I want its content to be hello world. All right. Now when I run Plumi up, I'll see a preview again of what changes are going to be made. And this time, instead of creating both of these resources, like I would if I was running a typical sort of imperative program, we'll see we're only going to create the new object, right? Only the change that I made, only the thing that's different from what's already deployed. And so you can tell this program is really describing sort of the desired state of my infrastructure. And every time I deploy it, I'm sort of updating my infrastructure to match this new desired state. And so in this case, I'm going to create that bucket object. You'll see it has the hello world content and the key obj. OK, I'm going to go ahead and deploy that. Now, so far, this is sort of just standard. If you use Terraform, if you use CloudFormation, something like that, this is looking fairly familiar to that kind of experience. This is just infrastructure as code, right? The only difference is I get a little bit of IDE experience, get a little bit of type checking. So if I mess up the names, I get feedback on that right away. A lot of these simple things, but really it's fundamentally the same. Where things start to change is when I can sort of use all the capabilities of the underlying platform. So I can say, use a for loop, right? So I can say for each file name in this directory. So I want to create one of these objects for each file name in this directory. And so I'll use the file name as the name of this thing. I'll use the file name as the key. And instead of hard coding the content, I'll read that off of disk. So I'll just say read file sync. And just do a little bit of Node.js stuff to combine the root folder with the file name. OK, so there we go. I've written a little loop over that creates my infrastructure. This is using some files on disk, going to find out what they are, going to put each one of them up into this S3 bucket. And so this is still infrastructure as code, but here I'm actually describing that desired state by doing some computation, using some libraries from Node, that sort of thing. So it's starting to feel a little bit more like code, like something that's programmable. One thing you notice, I get a little squiggle here. I'm actually getting some of this feedback. It's telling me I can't assign a buffer to a string. And in fact, that's because I have a subtle mistake here, which is that I need to describe what encoding this file is in before I upload it. And so that's kind of feedback I can get from my IDE here. So I'll just go ahead and update this. And we should see now we'll actually delete the old object we had and create two new objects. And so we're going to change the infrastructure here. If I scroll up, we'll see we're creating these two new ones, the index.html and readme. And I'm going to delete this object. And so I can see the details of sort of what's inside those. This one has some markdown in it. This one has some HTML in it. And I can go ahead and deploy that. OK. So we can use things like for loops. Now, one of the things, though, I've been sort of doing this iteration of going back and editing some code and then running Plumi up. One of the things that we've just added recently is sort of an experimental capability, something that I really think is interesting, is the ability to sort of do this interactively. So I can say Plumi experimental true and then Plumi watch. And now when I make changes to my code, it's just going to automatically deploy them. And so it feels a lot more quick. So if I want to make this sort of a public website, for example, I can say index document index.html. Now I hit save, and you notice it starts updating immediately. And so now I can continue working on my application as it's sort of updating in the background. And all of this is deploying into AWS as I make these changes. So I can make a few other changes along the way. So to make this something that's accessible publicly, I'm going to make it public read ACL. And I'm also going to make the content type be text HTML. And finally, I'm going to export the URL. And I'm going to export that bucket endpoint. OK, so we're doing updates as we go. So we're sort of seeing this application now. All these cloud resources are sort of just magically appearing. As I'm editing my code and hitting save, we're creating resources. We're updating resources. The cloud environment is sort of changing right as I type this code. Now I can come over into a new output here, and a new window here, and say Plumi stack output bucket URL. Get the URL that I just exported there of the running application. Come over into a new window and open it, and there we go. So I've got a little static website being hosted out of a few files. And just kind of wrote that using some code, using that interactive sort of development style, all just in a few lines of code. And so it feels quite different, I think, than for those of you who've worked with CloudFormation or something like that, the experience here is very different, even though sort of what we're ultimately doing is working with a lot of the same primitives. One last thing I'll talk about just from a perspective of sort of software engineering is I can take this sort of function here which syncs these files into a folder, and I can even just give that a name, right? So I can say sync dir. I can take two things. I'll take the bucket I want to sync it into, so I can say, S3 bucket. Oops. And I want to take a dir, which is a string. And I can just say, hey, I want to make this into a function that I can call, right? And now I'll call sync dir. Oops. And now instead of hard coding this files here, I can just set the dir, oops, and set the dir here, right? OK, and so now I've taken that and turned that into, I've given that function a name, right? And so I've abstracted away that capability to sync a bunch of files into a directory. And you actually see that update didn't change anything when I made that change. I refactored my code, but it was sort of observationally exactly the same. It was creating the same resources. But I could go further here, right? I could sort of document this. I could put it in its own NPM package. I could put that NPM package, publish that to NPM, and reuse it across multiple projects. And so a lot of these sort of core software engineering capabilities I have because I've turned this thing into a reusable function and a reusable piece of code. All right, so that's a quick sort of overview of kind of using Pulumi to sort of do infrastructure as code for developers. So one of the things that I think is sort of most interesting about that last example was that sort of that kind of watch mode that I showed, where I was sort of being able to interactively develop code and develop infrastructure as I edited. And one of the things that reminds me of is sort of this this demo that many of you may have seen of Brett Victor did this talk back 10 years ago or something, where he kind of showed off a whole bunch of things with sort of developing in environments where you are able to interactively modify the code and immediately see the results of it inside the application. And how by doing this, by closing the gap between when you were writing the code and seeing the impacts of that code, every time you could meaningfully decrease that gap, it enabled people to be so much more creative because they could see the results and feed them back into their thought process immediately. And so this idea of being able to have this really tight feedback loop is one of these things that I think is really critical for kind of application development. The tighter you can make that loop, every sort of order of magnitude faster you make that, the more that people can sort of take advantage of these building blocks and use them in really interesting ways. And so this is one of the things with cloud development today. I think a lot of places, cloud development feels very slow. In many organizations, you have to throw it over the wall to some other person who has to go and do the work for you, either an ops team to provision some hardware or a DevOps team to sort of tell you what you're allowed to do inside the dev environment. And even when you do have access to it yourself, a lot of the cloud provider primitives are themselves fairly slow to use. But there's an increasing set of these cloud primitives that are actually very fast. Things like what I showed with S3 buckets, things like serverless functions, things like containers in Kubernetes. We can actually do this kind of iteration very effectively. And there's lots of tools in practice that are doing this today in other parts of application development. Things like Chrome DevTools, the ability to just immediately understand what's happening inside your website and be able to modify it live inside the DevTools, created this really different way of thinking about web development that has really made web development substantially easier than it was sort of in prior eras of web development. And even in the cloud space, there's other folks sort of working on this problem. And so one that I am a fan of is something called Tilt. This is a project in the Kubernetes space that's actually trying to sort of take the same approach to really tightening this feedback loop for the way that we develop and deploy Kubernetes applications. So we don't have to go and run those things and test those things on our local machine independently. We can actually sort of do that inner loop development cycle directly inside our Kubernetes clusters. And so that's a really interesting project. And then Dark, which has a talk in this track later this afternoon, is taking all this even further and saying by rethinking the whole stack for deployments, rethinking the programming language and the platform that we're going to run on, can we take this from a couple of seconds to this deployment to tens of milliseconds to do this deployment, to make it so that every time I change my code, I'm immediately seeing that deployed into runtime. And so I'm really excited about this general direction of enabling that. So one of the things that I think happens, around a number of these things, when we're thinking about sort of this idea of me, every time I change my code, I'm sort of deploying a delta into my running environment, it makes you sort of wonder a little bit about kind of what is the process model, what is the execution model that these programs are using. And so I want to talk a little bit about sort of process models, just as sort of background for how I think about why this sort of environment is different and what it means as a developer trying to target this environment. And so sort of imagine, one of the environments that we have, and I'll sort of talk about this from a JavaScript perspective and how JavaScript itself has evolved. JavaScript started in sort of the web, right? And that was the execution environment, was the page. And every time I navigate from page to page, in some sense, my entire world gets torn down and restarted up again with some different set of JavaScript. And so everything's very transient in this execution environment, right? Like I sort of have these pages are very short-lived things. And I sort of load my code in via script tags, and sort of everything is very stateless. Everything that I want to be stateful, I have to send off to some API server or something like that to sort of manage the state. But my application environment itself is this very short-lived thing that sort of has no long-term state associated with it. Further along in JavaScript's lifetime, sort of Node.js happened, but certainly sort of the thing that probably folks here are most familiar with this sort of a process model is sort of the server process, right? The idea that I have some operating system process. And folks often think about these things as sort of living for a long time, right? I run my process on my server, and it lasts for days, months, years, potentially. But one of the key things about processes is that they do sort of fundamentally have this idea that they have a finite lifetime. Right? Either they crash because I did something bad in my process and so it died, or the machine they're running on crashes and so they're no longer there, or I want to update them. I want to run a new piece of code. And so the only way for me to run a new piece of code is to actually deploy the new piece of code into a new process, tear down the old process, and make sure that anyone who is using it is pointed at the new thing. And so processes sort of fundamentally have this notion of a finite lifetime that they're going to run for. You can deliver these through sort of ELF binaries or Windows XEs or what have you. And again, still processes are largely stateless. Because they can die, their state is sort of managed somewhere else, either on disk or in some operating system or other concept that's going to maintain the statefulness. And so in the cloud, I think there's this other kind of process. And this thing doesn't really have a name as far as I've never seen some sort of standardized name in the industry for this. In Pulumi, we call it a stack. But it's sort of the idea that I'm going to deploy some infrastructure into the cloud. I'm going to deploy a sort of a serverless function, for instance, right, into the cloud. And it's going to be there forever. Right? When I deploy a serverless function, it doesn't matter if any given process dies, if any given EC2 instance underneath the hood dies. That serverless function logically exists forever and has an endpoint that's accessible that's going to access it. And so this notion of sort of an execution model where the thing I've deployed is a process that's going to run forever. And every time I want to make a change, I don't make a change by deploying a new XE or deploying a new JavaScript bundle. What I do is I make a change by describing a new desired state and telling some orchestration tool to drive my environment, my existing environment, which is still running, into that new state. And so this is sort of more like, for folks who have used things like edit and continue. This was a big thing I remember when I sort of started my career was sort of VB6 had edit and continue, and in .NET we didn't have edit and continue. And it was this big deal to bring edit and continue to .NET for the first sort of 5 years I was working at Microsoft. And this idea of being able to sort of take a running application, make changes to it while it's running, but keep it running and keep its state all sort of consistent, it really changes the way you think about developing applications. And I think this is one of the things with sort of cloud infrastructure is that one of the reasons they feel so different is that they're not just a process. It's not just I go onto a VM and I restart the process and I'm all good. It really is that this application I'm developing is one that's going to run effectively forever. I need to edit it as it's running. And so I think that's sort of a key new idea that changes a lot of these things. So one other concept I wanted to touch on really quickly is sort of the applications and infrastructure piece, right? And one of the interesting things that I've noticed is in a lot of environments, sort of applications infrastructure is not sort of a unified thing. They're actually treated very differently, right? In many organizations, these things are owned by entirely different teams. Even in organizations where they're owned by the same team, they're often managed in separate repositories, and so managed as totally separate code bases. And even when they're in the same code base, like in this sort of architecture example here, they're driven off of sort of different deployment pipelines, right? So along the top route, we sort of deliver our application code, and in this case, a Docker image, and we push it into some container registry. And then the bottom route, we deploy some infrastructure as code, in this case using CloudFormation, and that maybe deploys our cluster and our services into the cluster that take advantage of the application that was built above. But this idea of sort of separating these things and having them be run very independently, it can be good for a lot of reasons, but it really often decouples things which are meant, or which there's reason to think they should actually be more coupled, right? Where by coupling them together and deploying them and versioning them together, things would be a lot simpler, and pipelines like this wouldn't actually be necessary anymore. And so one example of this that I'll show in a live demo in a second, but is this sort of piece of code here, right? And so this is some Pulumi code again. And it looks, at the first blush, just like a normal piece of sort of infrastructure, right? I'm saying I want to have this cloud.task thing, which represents a containerized task that I can run in the cloud. And I want it to have, it's the desired state is I want this Fargate task. It has 512 megabytes of memory registration. But then there's this line that's interesting. It says build, and then this local folder, right? And so what does that line do? Well, that line says, in my desired state, I want to be running the Docker image that was built from that folder. And so you think about, well, what does that mean? Well, it means I have to actually, I need to have a registry in the cloud where I can put that Docker image, right? And so when I do this line of code, Pulumi underneath the hood is actually going to allocate a Docker registry for me in AWS. It means I need to build that Docker image locally on my machine, because whenever I'm doing this deployment, that's the code I want. Whatever code is in that folder is what I need to deploy. So I'm going to run a Docker build. And then it means I need to actually push that Docker built image up into the registry. And so all of those steps are sort of taken care of automatically here. But it means we actually version these things together. Every time I deploy my infrastructure, I get whatever the latest application code is. And these things version identically together. And this is a very different way of thinking about these things than we often do when we sort of separate out the notions of how our infrastructure and how our applications evolve. And Pulumi is by no means the only place where this happens. I think one of the places you see this a lot is actually in something like Docker Compose, right? So one of the reasons why developers really like using things like Docker Compose is they let them sort of couple these things a little bit. They let them create a little infrastructure environment locally on their machine that describes how their sort of application service or their piece of code they're writing can run inside a sort of environment that includes the database, includes the network, includes whatever other pieces of infrastructure they want to run, but can actually pick up whatever the latest code they have is and run it inside that environment. And so Docker Compose, I think, is one example of this. Another one is serverless. Both serverless, the general technique, and the serverless framework really encourage this idea that we couple our sort of deployment of our code and our infrastructure. Because inside serverless, we often don't have a distinction that the code makes much sense outside of the infrastructure. The entire way that we can sort of invoke that function depends on how we've hooked up the infrastructure around it. The logging of that thing depends on how I've hooked it up to my logs. The sort of access controls are all based on IAM and things like that. And so when we do serverless, we often are really naturally sort of driven to a world where we version these things together. But I think there's actually reasons why this stuff can get integrated more and more. So let me show one example of this that goes a little bit beyond even those examples back in Pulumi. And so I'll just show it right here. In this case, I've got the same application I just deployed, which had the bucket and some objects inside the bucket. And so one of the things we can do inside Pulumi is we can look at this bucket object, and we have a bunch of properties on it that give me access to all these different things. But you notice there's also these two functions. There's onObject created and onObject removed. So these are functions which actually allow me to hook up callbacks onto my infrastructure. And so I can say, new object. And I can actually just hook up a callback right here. So I can say, when this is called, I want to just print out this EV object, right? And so I hit save, and this is actually going to go ahead and start deploying this infrastructure. And the interesting thing about this is that this is actually sort of two things, right? This is some infrastructure, right? This is going to be, you're going to see a bunch of things down here that are getting deployed, a bucket event subscription, a Lambda function, an IAM role, all the things I need to sort of deploy this capability. But it's actually also some code. So this code inside here is code that's going to actually run at runtime, right? So when my bucket gets a new object added to it, we're going to run this piece of code here. And so we've taken this idea of coupling the sort of infrastructure and the application code to quite a bit of an extreme here by actually incorporating them into the same sort of source file. These things are really versioning very closely together. Now this update is completed. And so now if I make some change, like I come in here and say, hi, QCon SF, I can hit save. This will do an update, which should actually deploy that bucket object. And because I changed an object inside my bucket, it should invoke this function. And in a couple of seconds, we should see that this logging actually gets run, and I get the logs back into my ID here. The round trip time for CloudWatch is sometimes a couple of seconds, so I'll just wait for it to finish here. There we go. So we see now we're actually getting the logs from that runtime capability as well. So whenever an object gets added, we're going to get that log sent, and that's going to be in CloudWatch somewhere, so I can access it from the AWS. But it's also here within my development environment. And so I'm now actually combining into my development environment kind of both this infrastructure changes that are happening and some of these runtime changes that are happening. And so really sort of getting this sort of inner loop development quite tight here. OK. So one of the things that I think happens related to this is sort of when you look at the sort of world of kind of, I call it pre-cloud here, but really this is also sort of what for a lot of people is the cloud, right? But it's sort of this transitionary period of cloud where you're sort of doing lift and shift. And everything is still very VM-based. I'm running my own processes inside my own VMs, and my provisioning is saying what I want to run inside these VMs. And when I moved to cloud native, I moved to something like what's on the right. And when I say cloud native here, by the way, I don't mean I don't mean Kubernetes. I think for a lot of people, cloud native means Kubernetes. For me, I mean native to the cloud. So I mean using sort of the native capabilities of the cloud. And I might have some infrastructure or architecture like what's on the right, right? So I have some API gateway and Lambda. I have EKS and S3, a variety of these sort of higher level managed services that I'm using. And you may look at this and say, oh, that right-hand side looks way more complicated, right? Like, why would I want to move to this world? That looks terrible. And I think in some ways, it is. There's more stuff here, right? There are more moving pieces in this kind of thing. There's more that you have to understand. The thing that's really key, though, about the right-hand side is that the operationally complex parts of this are sort of these gray boxes, right? The pieces that I have to, that I own the operational behavior of and don't get to outsource that to a cloud provider are the application code I'm going to run inside these little boxes. And whereas on the left, I sort of owned the operational context of that whole VM. I owned everything about what was running inside that VM. In these sort of cloud native kind of worlds, I offload a lot more of that complexity onto some cloud provider, and I now own these sort of boxes here. But the thing I trade off for that sort of operational complexity benefits is I now own all these arrows and all these edges between these components. I own describing how all these things are hooked up. My application sort of logic is now embedded in how API gateway is hooked up to Lambda. This is no longer something which is just the infrastructure. This is sort of essential to the correct behavior of my application, is how are all these things wired up together. And so I think in these kind of architectures, it's no longer the case that sort of your application code and your infrastructure are separate things. They're all like very tied up together, and they're all sort of something that's going to have to version together in much more interesting ways. And so to sort of give a concrete example of that, let me talk about sort of this idea of kind of programming architecture diagrams. And so I'll show this one simple architecture diagram here. This is the kind of thing, if you go to reInvent and you go to Werner's talk or something, and he'll show up all these diagrams of all these AWS services and how they're all hooked up together, and you look at them all and you say, I kind of get what that means. I kind of get what they're doing. I'll go and take that idea and I'll use it in my job when I get back to it. And it's always like you see this thing and you're like, totally get it, right? In this example here, I'm going to take a video, drop it in a bucket. Whenever a new file gets dropped in that bucket, I'm going to fire this Lambda. That Lambda is going to spin off some long-running ECS task. It's going to run some container that runs, in this case, FFmpeg. And then that FFmpeg thing is going to do a keyframe extraction and drop a JPEG into a bucket and fire off another Lambda. So I can kind of look at this in a couple sentences. I can describe and understand what it's doing. But if you went and took this and said, oh, I'm going to implement that, right? It suddenly gets scary, right? Like, this is not easy to implement. In fact, you look at an implementation of this, and it's 500 lines of CloudFormation or so to kind of build just the infrastructure around this. It's a whole bunch of sort of application to delivery pipelines that I've got to do to make sure that those two Lambdas in that ECS task are all getting deployed in sync with my infrastructure. It's surprisingly complicated to actually build the kinds of things that are in these architecture diagrams. And so let me show you kind of what this sort of thing looks like, can look like, in something like Pulumi. And so this example here, I'll just show this part. So this example here, I've collapsed a few pieces of it just so I can talk through it very briefly. But this example here kind of encodes that entire architecture diagram in a real running piece of code in just about 40 lines of code or so, right? And so you can see the various pieces of this. So we've got a bucket, right? That was in the architecture diagram. This is where I'm going to store my my video files and my images. I've got this long-running Fargate task, this long-running compute piece, which is going to run FFmpeg. And if I look at this, it's actually exactly that code I had on the slide earlier, right? So I've got my memory reservation, but then I've also got, I want to build whatever's here. And if I go and look at that, I can see that's just a folder here with a Docker file in it. This could be my Java app, my .NET app, my Go app, whatever it is I have. In this case, it's actually just effectively some bash that runs FFmpeg inside a container. But it can run whatever I want, and it'll actually build that image from whatever source code I have here and deploy it directly. I can then say I have two event handlers. So I have one that says when a new MP4 file gets placed inside this bucket, run some code. And here I've got when a new JPEG gets placed inside this bucket, run some code. And probably the most complicated part of this, as is normally the case, is just sort of the parsing and passing data back and forth between things. So here I've got to kind of parse some of the inputs that come with the image that gets uploaded, and I've got to pass those into the Docker container as environment variables. But effectively, all I do here is I just take that task that I had defined up here, and I run an instance of it whenever a new video gets uploaded. And then as soon as I'm running that, I write out a log entry, and then whenever it's finished, when the JPEG gets uploaded by the task, we're just going to print out that it finished. And you can imagine extending this, right? I could, if I wanted to have some data store that kept track of what's running and what's finished, I could have add a new table in here and write that information in. Very easy to sort of extend this to more complicated infrastructures. But the key thing here is really just in 40 lines of code or so, at the level of that architecture diagram, I'm able to actually sort of develop something which represents the task at hand. And so again, sort of Pulumi is definitely not the kind of only tool kind of looking at this. And in fact, the AWS CDK, which just GA'd earlier this year, and I think there's a talk on it next, is doing a lot of really interesting stuff here specific to AWS, where taking some of these patterns and making it really easy in higher level ways to work with them sort of at the level of the architecture, not just at the level of the individual building block services that AWS provides. And really like some of the stuff that CDK is doing. In fact, this notion architecture as code, I really loved this. Claire Liguri at AWS wrote a blog post recently, a really great blog post about this topic, and used this word architecture as code, and so I'm stealing it from her because it's such a good phrase to sort of talk about turning these architecture diagrams into code. So there's one kind of last demo I wanted to quickly show, and that's focused on this tweet that I saw a couple weeks ago. And someone wrote out this tweet, said, I want a website that does one thing. It displays the number of times it's been viewed. What is the shortest number of steps you can think of to get it running in the cloud, right? And it sort of feels like a trick question. It's like, this shouldn't be that hard, right? Like, I just want to, I know how to build a website that has a counter on it. Why is this sort of a hard thing? And actually, a lot of folks jumped onto this thread and sort of responded with, for various different tools, kind of the steps you can go through to kind of accomplish this. But it is actually a surprisingly kind of hard thing to do. And so I wanted to sort of bring together a few of the ideas I've touched on here to show kind of one of the ways with Pulumi where you can kind of do this today. And so I'm going to claim I can do it in 90 seconds. We'll see if that really is true. So I'm going to start by I just have an empty slate here, and I have that same kind of watch thing running. And so I'll just sort of write out kind of what I would do to build this website that has a counter. And so the first thing I'll do is create a table. And so I can say new cloud.table. And I'll just call this counter. I hit save, and it's going to start deploying this. And then while it's deploying that, I'm going to create a new API. And so this will serve my website. Now I want to say api.get, so I want to route on this thing. So whenever I get the /route, I want to run some code. Oops. And you'll see this is sort of, for those who've used Express.js or something like that, this is using a similar style to that. And I'll just res.end. I'll say hello world. And now finally, I want to export the URL that this thing is going to be at. So export const URL equals api.publish.url. OK. So when I hit save now, it's actually going to go and deploy that API as well. And while that's going, I'll actually implement the logic of this application, right? So I can say something like, const counter equals, wait table.get. And I'll just get the entry that's called counter. Now, this entry may not exist, right? Because the first time I hit this page, there's nothing there. And so let me just seed it with n0. And now I'll say, wait table.update. Same entry. And I'll write out n is counter.n plus 1. And now, just as a final thing, I'll just say scene counter.n plus 1 times. OK, so now we're going to deploy and see that. And so now I can say Pulumi stack output, get the URL, go visit that. And assuming that Lambda spins up quickly, we'll see it's seen 1 times, 2 times, 3 times. There we go. So we have a counter. So we're just a few lines of code in Pulumi. We use that fact that we can use that watch mode to sort of iteratively deploy this thing. And we very simply kind of built that application. And this is sort of that experience, that developer-centric experience. If I want to be able to express my ideas very quickly in sort of a programming environment, but deploy those into a real sort of cloud application, I can take advantage of all the capabilities of AWS here. OK. So I don't know, was that 90 seconds? I don't know if it was quite. OK, let me drop back and just give one slide summary here. So for me, sort of, when I look at this, that example I just showed is I kind of think it's really exciting that you can do that sort of thing. But that's sort of really still for a somewhat narrow scenario that kind of we offer that kind of capability with something like Pulumi. And I think there's still a ton of opportunity to take a lot of these ideas and move them further forward. And I think a lot of folks are kind of working on pieces of this. But there's a few things that I sort of have no doubt are going to be part of the future of kind of how we work with the cloud platforms. And a few of the things that I really think about a lot. One is these frameworks on top of the raw building blocks of the cloud. And so you saw me using those throughout some of these demos, these higher level things like this cloud framework that I was using in the last demo, that are just easier to use than the raw building blocks. And that doesn't mean I won't sometimes want to reach for the raw building blocks, just like I sometimes reach for my file system access APIs on Windows or whatever. But a lot of the time, I want to use that high-level Java file system API. I don't want to be stuck with those low-level building blocks all the time. Another one is sort of unifying application infrastructure code. I continue to believe this is sort of going to be a trend to sort of move these things closer together, especially as we move to more cloud-native architectures. I think we're seeing this with serverless, we're seeing this with Kubernetes, and I think this is going to continue to be a thing which we see more integration of these two things. And that's actually going to drive sort of the teams integrating more, so more of this responsibility moving into development teams, and development teams being able to take ownership of more of this. This idea, I sort of talked about these process models and this idea of this sort of long-running kind of cloud process. I think is an important way to think about this stuff and really starts to raise questions about like, well, what about if I need to do database migrations? I've got this long-running thing. How do I script those kind of database migrations into these kinds of deployment processes? And I think there's still a lot to be discovered around that and a lot of sort of innovation that's going to happen there. And then finally, I've kind of spent a bit of time talking about how important this sort of rapid iteration is. And I really do believe that that's one of the things, the idea that the cloud platforms feel like they're at your fingertips, that this isn't something I have to throw over the wall to somebody else, that I can immediately see the results of what I'm doing. I think this is going to really change the way folks think about being able to work with the cloud productively. And so sort of in summary, I'd say I sort of believe that over the next few years, kind of every developer is end up going to be a cloud developer to some extent. Everyone's going to be touching the cloud as a part of the way that they develop and deploy their applications. And so I see a huge opportunity across all of these for the industry and for all of us as developers to take advantage of this. So with that, I'll say thanks and take a few questions. Thank you.
Thank you, Luke. So if you want to ask a question, stand up or raise your hand, and I'll make my way out to you as quickly as I can. Great. Easy.
Easy one. Is Pulumi production ready?
Yes, so we actually, Pulumi itself hit 1.0 a couple months ago, I think. So it's been, I think we were working on it for about 2.5 years, and it's been out publicly for a little over 1.5 years now. So we have a lot of folks using Pulumi in production today, and the sort of core of it. A lot of the things I demoed here are things that are kind of higher level, as we had some experimental features here. So some of what I demoed here today is definitely more on the edges of kind of what we're doing. But the core platform, the core infrastructure as code offering is definitely being used in production today.
If I wanted to learn more about Pulumi, where would I go?
Pulumi.com. Yeah. Pulumi.com has a ton of resources, getting started information, and a whole bunch of guides and things like that.
Is Pulumi mostly integrated with AWS? All your examples were in AWS.
Yeah, no, it's always a tough thing because I want to show some sort of continuity of what we're doing, and so I did focus on AWS here, but no, Pulumi is sort of equally accessible across AWS, Azure, to some extent, everything I showed here is something you could do on those other platforms as well. AWS is probably where the single largest user base of Pulumi is, but there's large user bases across the rest of those as well.
Yes, how do you account for, in large teams, the state management and the infrastructure drift?
So infrastructure drift, I think there's a couple of, Pulumi itself has a bunch of tools for how, in infrastructure drifting, it's often is somebody else on the team is going behind the scenes of the infrastructure's code and changing something in the console or deploying something from their laptop that wasn't actually checked into the main code base or something. And so Pulumi has a bunch of features to sort of deal with that. It has a Pulumi refresh, which goes and make sure the state matches what's actually in the cloud provider. You've got tools like the ability to import existing resources from the cloud if you've got things that are out there that you want to bring into your environment, but you don't want to have to recreate. There's a whole bunch of tools, there's sort of operational tools around dealing with this sort of thing. You can also do things like catch whether, when you do a preview, you can see whether the changes are something you're going to actually expect to happen. And so I focused a lot on sort of that inner loop experience, which is sort of a bit different. When folks think about infrastructure as code, I think they more think about this sort of thing. They think about the sort of operations for running this stuff in my production environment. And Pulumi definitely sort of has the full sort of tool set for that use case as well. Today I really wanted to focus on the other side, which I don't think gets as much attention, which is how do we make this stuff more accessible to developers. But certainly for the sort of production environment, there are a bunch of those tools to make sure you can robustly manage a production environment.
Which programming languages are supported? And second part of the question is, where is the state being stored?
Yeah, great questions. Today we support JavaScript and TypeScript, we support Python, and actually just today we launched in preview .NET support, so C#, F#, and VB, and Go and Java are on our near-term roadmap. So that's sort of the core language we have today. We're going to continue expanding the language coverage. And on the state question, the default in Pulumi is actually to use, there's a free tier of a Pulumi service backend which you can use. So you don't have to worry about state at all out of the box. It just gets managed by the Pulumi service itself. But if you want to manage it locally on your machine or in S3 or Azure Blob Storage or whatever, those options are available as well, and you can just log into whatever backend you want to use to store the state. But we try and make that something that most users of Pulumi don't even have to think about. But if you don't want to trust those files to go up to Pulumi, you can take it yourself.
Hi, what does it look like when you're deploying to multiple environments with something like Pulumi, right? So I'm developing locally, I have the fast feedback loop, but then when I'm ready to commit it and push it to my test environment or production, what does that look like? What's the model for that?
Yeah, so I think that's a good question. Again, I focused a lot on sort of that very inner loop phase and during that development cycle, which I think is, in that phase you don't care so much about the infrastructure. If you break everything, it's sort of okay. You throw it all away, you start a new one, just like you would if you're developing your application locally and something goes wrong, you just kill the process, deploy again. But yeah, when you're moving it into sort of a robust test environment or ultimately into a production environment, that phase, you're typically going to put that into some sort of CI/CD system, right? And so Pulumi can be added into a variety of different CI/CD systems, and then you'll deploy, every time you push or every time, you go through some gated sort of deployment process, you'll actually go and do that Pulumi deployment, and potentially when you open a PR, you'll do a preview of what change would happen if you merge that PR, and then when you merge it, we'll actually push that into the environment that's being mapped. And so there's a lot of different techniques you can use there, but one that we've seen is just mapping branches in your source control into environments. So have a branch that's your testing environment, a branch that's your production environment, and as you merge bits through those different branches, it will actually merge them into that environment in your production infrastructure. And that's something largely you can sort of just script yourself using your existing sort of CI/CD tools in the same way that you might script CloudFormation or Terraform. But Pulumi itself does offer some sort of features in that service that help with that when you're using it.
Okay, I think one last question.
So with respect to AWS, how rich is the library support? Like, does it support all the resources, or are you guys working through it? Or does it support like most commonly used?
Yeah, so Pulumi itself has sort of support for, we project the libraries for AWS, Azure, GCP, Kubernetes, everything. So we project the full API surface area of those into the Pulumi programming model. And so everything is available there in the raw form. Now, some of the higher level libraries I used here, like these cloud doc kind of things, those are much more limited today. And we have some higher level libraries in some limited domains, in the serverless domain, in the sort of ECS domain, and a few others. But that's something that we continue to expand, those higher level libraries. We're looking at doing things around RDS. There's a lot of interesting things we can do to simplify the way that you work with databases in AWS. And that's something that, as we work with folks in the community and customers and things, we'll continue to expand those higher level libraries to cover more cases.
All right, I think that's it. Let's give it another round of applause for Luke.